Good people, we can now dive into division and the modulo. So here division using the forward slash as a division sign. You can say 10 divided by 5, right? So this will give us 2. We can say 20 divided by 5. This will give us 4. Now we shall do the samples, and you can say 50 divided by 10. This will give us 5. Basically, that's division. We have something called flow. Let's let me put this big. Okay. No. Okay. Okay. We have something called flow. Okay, this is basic division, just a division was done. And we have something called okay, maybe a little bit over what is that. When you use the forward slash, that's a division operator, and it returns a floating point number. Basically, when you say it will return 2.0, it returns floating point number 4.0. Sorry, 0.0. Sorry, it returns 5.0. So we have something called a float division operator. Float division operator is now the double forward slash. Sorry, a double forward slash is called float division operator. What does this flow division operator does? It is used to round down the result, the result of a floating point division. Closest smaller number. So basically, what we're saying is when you do 10, okay, if you have a floating point that has decimal 3.14, it will round down the number to 3, since it's to round down. So if we have a result being 3.14, meaning when you use the flow division operator, it will round down to the answer will be, that one will remain to 3. If we have I'll give examples of instances where the flow division operator is being used and how the result happens. So, for example, we say 20 point operator divided by 10. So this will give in a normal scenario, 20 divided by 10 is 2.0. In our normal division here, it will give 2.0. Now, rounding off to the closest small whole number, which means instead of 2.0, it will just give a 2. And then when it's 50 operator divided by 50, it will give 1.0. 1 and 0.0 is the initial division operator, but when you have a flow division operator, it will give a 1. Another example is 5 divided by 10. So in a normal scenario, it will give 0.5. 5 divided by 10 to give half 0.5. So basically the result will be 0. In a normal scenario it's 0.5, but when it's when we use a flow operator it will give us 0, because 0.5, the lowest, becomes 0. When we have a 5.0 2, in a normal scenario 5 divided by 2 is 2.5, but since we're using a flow operator, it will round down the result. So instead of 2.5 of 2.5, it is the answer is 2. So I hope that's clear. When we use a normal division operator, we give the answer, right? So if we say 5, let me use another example, is 5 divided by 10. 5 divided by 10, this will give 0.5, right? I hope that's clear. The difference between division and modulo, right? Modulo gives, sorry, not modulo. The difference between division, we'll go to modulo in the next example. The difference between division and flow division operator. The difference is the division is a normal division operator. Normally, it gives the answer to the floating point number, right? Normal division gives the answer to the floating point number. Flow division number round down the result. I hope that's clear. And we're clear up to there. I've shown you examples here. We can do example. We can see other. We can do just examples to see if, for example, if we get the answer, I think like 12 divided by 4. So the answer here will be 3.0, right? Let's see. So that's this is a normal division. So this is a division operator. Then 5 divided by 10 is 0.5. 5.0 divided by 2 becomes, when we use a modulo, it becomes 2. 100 by 0. When you divide 100 by 0, what do we get? 100 divided by 0. 100 divided by 0. Basically, it becomes undefined. You can try that in your VS Code, and then you see the result of this. Anyway, you're trying to divide 100 oranges by 0. Anyway, let's go to our second part of this discussion, whereby it's the modulo. So I hope we are clear on our explanation on the division and the flow division operator. I hope we are clear. Again, one final time before we go to modulo. Division returns the floating point of a number. 10 by 5 becomes 2.0, 20 by 5 becomes 4.0. That's the normal division operator. Here comes the flow division operator, whereby it rounds down the result of a floating point division to the closest whole number. Basically, it goes to the next lower number, right? For example, 5 divided by 10 becomes, it's normally 0.5. Now, since we're using a flow division operator, it will go down to the lowest number, which becomes 0. 5.0 divided by 2. 5 divided by 2, normally it's 2.5. But because we're using a flow division operator, it becomes 2. I hope you're clear up to there. And now we can move on swiftly to modulo, which is normally, its representation is the percentage sign. So we can say modulo is its sign is division, is a percentage sign. I hope you're clear. Now, what does modulo do? Modulo evaluates the remainder of division of two integers. Now, you have divided two integers. You have 5 and 2, 2 and 5, 3 and 5, whichever the integer you've divided. You've done a division of two integers. Now, so when you do the division, then you have the remainder. Now that's what the modulo evaluates. I hope that's clear. Let's do an example. 23 modulo 10. So what do you mean by here? Let's use this to get the real example, the real explanation of the modulo. Now when you say 23 divided by 10, in a normal instance, 23 divided by 10 is 2.3, right? So we have a remainder of 0. We say a remainder of 0.3, right? A remainder of 3. 10 in 23, 10 appears twice, so it is multiplied twice, and a remainder of 3. So the modulo here is 3. Hope that's clear. In 23, 10 appears twice. Basically 10 times 2 is 20. We have a remainder of 3. That's the modulo. Another example is 9 modulo 5. Here in 9 modulo 5, the answer becomes 4. How is that 4? In a normal instance, 9 modulo 5, the remainder is 4. How is that? 5 appears once. 5 appears once, right? And then we add 4 to it. So 4 is the remainder. Basically we're saying what's the remainder. So the answer there is 4. So 9 modulo 5. 9 modulo 5. The answer is 4. Let's just do something a little bit. 9 modulo 4. 9 modulo 4. What could be the answer? The answer is 1. Why is the answer 1? Because 4 appears twice. 4 times 2 is 8. The remainder is 1. I hope that's clear. That 9 modulo 5 is 4 because 5 appears once, and then now the remainder is 4. You have to add 4 to it to make it 9. For 9 modulo 4, basically we say 9 divided by 4 becomes 2, which is 8, which is remainder is 1. Basically the remainder. In our example here, 9 divided by 5, 1, and then the remainder is 4. Here we have the 4. Here it becomes we have 4 appearing twice, which is 8. The remainder is 1. So the answer is 1. I hope we are clear up to there. I can write many more examples. We can say another is 20 modulo 5. 20 modulo 5, the remainder is 0. Basically we don't have any remainder because 4 appears 5 times in 20. So the modulo of 20 modulo 5 is 0. Same thing to 20 modulo 4 is 0 because 20 modulo 4 is 5. 4 appears 5 times in 20. But that's clear. Basically we work with the remainders. Yeah, for the modulo we work with the remainders. I hope that's clear, and we can handle okay, maybe another example before we do an example. 70 modulo 7. Modulo 7. How many times does 7 appears in 70? It's 10. So there is no remainder. Is there a remainder? There is no remainder. So the answer is 80. Because we have no remainder. Because we have no remainder. Oh, that's clear. That modulo just shows the remainder. If we now had been working on 71 modulo 7, right? 1. The answer is 1 because 1 is the remainder. I hope that's clear. 1 is the remainder. So, hope you're clear up to there that modulo shows the remainder. In case there's a question, you can leave it in the comment section, then we'll handle it as we go along. Another example. 1 modulo 2. Basically, how many times does 2 appears in 1? So we'll say 1, right? Okay, this is a hard one. It's a tough one to handle because we say 1 divided by 2. We'll say 1, then the remainder will be 1. So okay, I'll say here 1. Basically, the other there becomes 1 because 1 multiplied by 1, so the remainder will be 1 in 1 modulo 2. I hope that's clear. The remainder is 1. I hope that's clear. We can do I guess let's do an example whereby we'll try to convert minutes to hours, and then we'll see where modulo comes in, where flow operator comes in, flow division operator comes in, and the division itself. So we're going to use hours, minutes, and seconds example now. So let's we'll call our sample minutes.py. Now we are certain that 1 hour is 60 minutes, which is 1 hour is 3,600 seconds, right? So we're going to use that to do a sample. So basically, let's first start with writing a comment of what we're going to do. And as usual, as I told you initially, these are the comments we use so that we can give a sample of what we're going to do in our file. So we're going to do minutes to hours conversion. Now let's get to this. So first we're going to check minutes from a user. As usual, to get an input from a user, we're going to use the int. Then we say input. This is how we get an input from a user. I hope in all our examples we have been using this to get input from a user. So we just say so we will say enter minutes. Now a user will type in the minutes, right? So we'll say now once the user has entered minutes, let's say they have entered whatever minutes they have entered X. So we'll say for us to get the hours equals to what they have entered divided by what they have entered in minutes by using the flow operator of 60 so that we get a full hour. Now, what do we mean by this? 1 hour is 60 minutes. So in case we'll find if a user inputs 61, right? Which means now let me just show now let me just copy this and then we use it in our example here in flow operator. Now, if a user has entered now the flow division operator, it will round down the result of the floating point to our closest small whole number. I hope by using this we get to know why we are using the flow division operator here, so that we get the hours rounded down to the whole number. If it was 2.6, so we have hours being 2, right? I hope that's clear, that we'll have it rounded down to the closest whole number. So we'll have the remainder of it. So I'll call it minutes remaining from where? Minutes remaining from what the user had placed. We'll say is equals to minutes modulo 60. We just from explaining what Modulo does. Modulo shows us the remainder. We get the remainder, right? I hope we are clear up to there. So now, what happens when we print this? I hope we are clear that minutes remaining. This will show us the remaining minutes, how many are remaining, and this will show us, the modulo will show us the hours to the lowest number, right? Lowest whole number. It will leave the remainders. Then this is where we land with the remainders. Let's try and print, and then we try running some minutes, then we see what we get. So let's print this. Let's print minutes we have placed. Then we hit text there. Yes. Now we pass the hours, since the hours is being passed in the lowest, the whole number, right? I hope we clear up there. And then for the minutes we're going to use the remaining minutes. So we're going to have hours and we're going to pass the minutes remaining here. Minutes remaining. We should be having it being preferred. So a minute. So we have the minutes which the user just input. The user just type the minutes. Let's say 135. So we should have a text saying minutes. Minutes is the hours. That's correct. No, yes, that's correct. That now work. So and minutes remain exactly. I was wondering why we weren't able to pick that. Minutes is hours and minutes. Remaining minutes. Is just minutes. Okay, hopefully this text works. Let's see. Let's try run it and then see if it works. So let's try it on our minutes example. So let's say I want to use 135. So it's 2 hours. Sorry, there's only 2 hours there. I admit. So this works pretty well because we're being told 135 minutes is 60, which we get from here. So the whole numbers we get from here, which is we use the flow operator, which becomes 2 point something. So we let alone the point we have the flow division operator, which just remains with 2 being hours here. I hope that's clear. Picks 2 here. In our example, when we use 135 minutes, from here it will just pick 2, let alone the remainder. Now we'll have the remainder. So now using the modulo, we pick the remainder. I hope that's clear. Now for the remainder, we're going to say those are the minutes we have. I hope that's clear. Up to there, we used this example to convert minutes to hours and minutes using the flow division operator and the modulo operator. That's it up to now. I hope this example really makes things easier. I'm going to tackle more examples in our next recording. Thanks for your time. In case of any questions, leave a comment, share, and we'll meet in our next recording. I'll try to handle more examples on the flow division operator and the modulo. Yeah, but this was a good example to show us to shed some light on the 2 operators. Thanks for your time. See you in the next one. Bye.